things we need. Now, we have to identify each of them. Number one, they said the molecular formula of all of them has been given. And that molecular formula is C4H6. First of all, what you have to first understand is that this molecular formula is for unsaturated compounds. It means the compound must have double bond or triple bond. Why? Because the hydrogen is not sufficient enough. You cannot have 4 carbon and be having 6 hydrogen. Because the number of hydrogen must be doubled of the carbon and even plus 2. That's alkane. Are we together? Now, it means that for butane, it has to be C4H8, H10, right? Because we have to double the 4 and plus 2, right? Now, if we are not having C4H6, it means it is not alkanes. It's either it's an alkane or it's an alkyne. That's already done. So it's unsaturated. Now, the first thing I will do is to know that this compound, all the compound must have 4 carbon. But you know, we are not limited. You know, all organic compound can either be straight chain, right? Branch, or what? Cyclic. So you now use that one to construct your 4 different compounds. Now, begin to take each of this. Condition 1, they say compound A give a positive test to silver nitrate and copper chloride. I have spent 3 years learning chemistry. I know that this reaction is for terminal alkynes. Yes. Terminal alkynes, they react with silver nitrate and copper chloride. What are terminal alkynes? Alkynes that have their triple bond at the edge. So since they have already told me that the molecular formula is C4H6, so I already know that this is but. That's our 4 carbon. Then I will draw a 4 carbon that have triple bond at the edge. That's the answer. So my A is going to be 1, 2, 3, 4. Since I have known that AgNO3 reaction and copper chloride reaction is for terminal alkynes, so the alkyne will be at the edge. So then I will balance the other stuff with hydrogen. This will be 1. This one, since it's at the edge, will be what? 3. That's compound A. We are identifying now. Then this will be what? CH2, right? And this one doesn't need anything. If you can't, how many carbon is there? 4. How many hydrogen is there? Does it follow the molecular formula given? Yes. So that's butane. So butane is compound A. Identified. So compound A is butane. So if somebody asks, how do you know now? How do you know? I know because I know that one of the unique reactions of terminal alkynes is that they can react with silver nitrate and copper chloride. That's why it's an assignment. Go online, search about it. What between terminal and internal alkynes, both of them can react with AgNO3 and CuCl. They will show you. Now the second one, compound B, they give you another idea. Compound B do not. We use this reaction AgNO3 and CuCl2 to distinguish between terminal alkynes and internal alkynes. You get it now? So since A is terminal alkyne, that means B will be what? Internal. Internal means just change the position of triple bond to somewhere in the middle. That is what? But2-ion. That's compound B. So compound B is going to be an internal alkyne. 1, 2, 3, 4. Please, guys, where will the triple bond be? Middle. Internal. To balance this is 3. To balance this is 3. To balance this is 1. And then you will not put anything here. Does it obey the formula or not? What's the formula? C4H6, right? How many carbon? 1, 2, 3, 4. How many hydrogen? 3 here, 3 here. That's how many? 6. C4H6. That's the correct. Compound A is but1-ion. Compound B is but2-ion. Terminal alkynes and internal alkynes. Then the third question. Give us the details of compound C. And what did he say? He said compound C undergo, you can zoom sometimes so that I can bring the board to you. Compound C undergo 1, 2 and 1, 4 addition reaction. I've told you 1, 2, 1, 4 addition reaction is for dienes. Compound that have double bonds 2. It's going to be but1,3 diene. You know everything must have 4 carbon now. So the answer to this one will be 1, 2, 3, 4. I know that 1, 2, 1, 4 addition is for dienes. So I will put double bond here. I will put double bond here. How will you know the compound? To balance this carbon, put 2 more hydrogen here. Have we? To balance this, how many hydrogen we put 1, right? To balance this, how many hydrogen we put 1 more, right? Then the last one here, how many hydrogen we put 2? Sum up the hydrogen. 2 plus 1 is what? 3. 3 plus 1, 4. 4 plus 2 is what? 6. 8, 6. Carbon, 1, 2, 3, 4. We are still correct. That's compound C. And this one will not be but 1, 3 diene. That means if you want to create an alkene that will look like alkyne in the same molecular formula, double the double bond. So when you also double bonds, the hydrogen will be enough for us. So but 1, 3 diene is another compound that you can use C4 to create, and it's possible. And how do I know that it's diene? Because I'm already related. I am used to 1, 2, 1, 4 addition reaction. 1, 2, 1, 4 addition reaction. We were taught during our own Chem 2 to 1. Then I don't know why they have changed the syllabus. So 1, 2, 1, 4 addition is for alkene. So I know that it's an alkene. So that means I must not even think of alkyne. But if you hear silver nitrate and CuCl is for alkyne, terminal alkynes and internal alkyne. Good. The last one, B, the only option they gave. Now, another thing you can use to get B is that they said, but B reacts with what? Ozone to get 2 mole of ethanoic acid. Anytime you perform ozonolysis for alkene, please, ozonolysis can also go for alkyne. I've forgotten that. If you perform ozonolysis for alkene, you are going to get alkana or alkano. But if you do ozonolysis for alkyne, you are going to get alkanoic acid. So if ozonolysis will happen here, the ozone will break this bond here. Oxygen will be here, oxygen will be here. That's COO. Then each of the COO, OH will join. OH will join. So that OH is COOH. That will be ethanoic acid, ethanoic acid. That's why they have given you the expo that ethanoic acid. So if you want to form it, just draw 2 molecules of ethanoic acid. In fact, it's from the back. This, you know that they have already told you that compound B give you 2 ethanoic acid. Write the 2 ethanoic acid and bring them together. Condense them like your other condensation. What we do? Remove water. By the time you remove your water, you are going to see that what you just do, remove all of this, their OH, then join them at that point. CH3. Remove the ozone, the 3 oxygen, then you be left with 1, and that does it. So it has given you a but2 which is this. So when you join 2 ethanoic acids together, the point of their joining is where the triple bond will be. So that's it. So that's another idea. That's why I know that actually I'm not wrong by saying compound B is but2 because when you cut it at that center, you get 2 molecules of ethanoic acid. So you can also use the ethanoic acid to get the answer. Just join the ethanoic acid together. Remove the OOA that they are having. Let it be CH3 carbon. So compound B undergoes hydrogenation in the presence of a nickel catalyst to yield cyclobutane. For you to yield cyclobutane by hydrogenation, what is hydrogenation? It's under which type of reaction? Addition reaction. Reaction 1, right? If you perform hydrogenation, hydrogenation is to supply who? Hydrogen. And if hydrogen comes into the chain, it's there to break the bond. That means the compound must have been something like alkene or butane before it now turns to what? Butane by hydrogenation. And you cannot be cyclo suddenly. You must have been cyclo before. Okay, now that means compound B is cyclo already, even before the hydrogenation. That means our knowledge must think about a 4-carbon cyclo compound, and that's cyclobutane. Butane. So it is that butane that now got broken by the hydrogen that now becomes cyclobutane. Do you get it now? That's just in your brain. So that means this one will be this, right? Put the one. So when you hydrogenate this edge, hydrogen here, then you break this bond, and a compound that does not have any double bond again is a butane, cyclobutane. So that means the compound B will be a compound like this. Now let's now count. How many hydrogen is here? Each edge is carbon, right? How many hydrogen will be here? 2. How many will be here? 2. But this one have double bond. How many will be here? 1. Count the hydrogen. Is it up to 6? 2 plus 2 plus 2, that's 6. C4, H6. It is the same thing. So that's the 4 compound. Do you agree with that? That's the identity of those compounds. So what was compound 1? With 1 ion. What was compound 2? What was compound 3? 3 diene. And what the last one? cyclobutane. Are we together? Now, it has tell you that this person is what? Terminal alkyne. What's the nature of this person? Internal alkyne. What's the nature of this person? Diene. What's the nature of this person? Cycloalkene. Alkene that are in cyclic form, they are called cycloalkene. So now, the reactions that are unique to them. Now, let's now answer our question. Give the structural formula of A, B, C, D. We have answered that. That is structural formula. But this formula can even be the condensed form formula. If you are asked to draw the structural formula, show all the hydrogen, please. So this is not correct. If you want to draw the structural formula of A, the structural formula of A will be C, hydrogen, CH. Just show the hydrogen the way they are and do like this. That's A. For B, it's going to be C, hydrogen. That's structural. And the last one is, it's better to use this than to use the other one. And the lecturer will now said, I don't want that one. Okay. Two one 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 CH2. Yes. Okay, you can make it like this to avoid issue. So this is more correct. You can make it like this so that they can be in the same axis. Then the third one going to be, that's the structural formula. If you draw this, then you are correct. If you do this formula that I draw on the board, it's condensed formula, and it's this is your mark. Though they will still mark it. Maybe instead of 2 marks, you get one mark. Structural formula, you have to show. Yes, you have to show either the lines or you use Lewis structure dot. In each line is 2 electrons. It's also allowed. You write carbon, you have 12 dot like this. But this one is the most important. That's okay. So if you draw this, you have gotten question 1. What compound will be formed when D, go to your D. Your D is a cyclocompound. When D undergo oxonolysis. Oxonolysis is a reaction that will target the double bond. Ozone is O3. Out of the 3 oxygen, 2 is the useful one. 2 of them is useful. So that means you have to react this with ozone. It depends on zinc and water. So what will happen is that 2 of this oxygen will be given out. Only 2, please mind you, in ozonolysis, out of the 3 oxygen, only 2 is useful in the reaction. What will happen is that the 2 of them will come. They will come to where this double bond is. They will break it. When they break it, each of them will attach to the edge. So as they do that, they are going to break the cyclic compound open. As they break it open, it's not as if they are adding any carbon to it. So now straighten your chain. Your chain is not like this. Just assume that this edge is where they are joined together. You know they are already unique before. Once they are broken, they are straight back. That means it's an alkana that has representation at both edge. What will you call this? You will call this boot 1,4-dia. That's the name. Because alkana has their oxygen at the what? At the edge. And we are now having oxygen at both ends. You are going to locate the number of the 2 ends. And that's the answer. The answer is going to be, so but balance the hydrogen so that your marker will know that you know what you are doing. Balance the hydrogen. Please, don't ever leave the hydrogen unbalanced. I just show you so that it will be easy for us. Like, how do you balance the hydrogen? Make sure each carbon is burning 4,4. So the name of this compound is no longer cyclo. That means whenever you perform ozonolysis to a cyclo compound, it's going to give you either alkana. It's going to give you alkana or alkano. But it will no longer be cyclic. The cyclicity will break. Because that's why I call it a cleavage reaction. A cleavage reaction. You get it now? So it will be boot 1,4. Why is it 1,4? If you take this one as 1, this will be 4. If you take this as 1, this will be 4. So both one fall. Yeah, that's it. So that's the answer to that question. It's a past question and it's part of the question he gave to you guys. And they are very, very simple. If I'm giving this one, within some seconds I'm done now, or maybe 2 minutes ISF. Because already I have the hint. It's very, 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 very easy. Listen. So when a metal gets involved in acrylamides, it's not even only acrylamide. When metals get involved in organic compounds, when they are in alignment, we call them organometals, organometallic compounds. So acrylamides can react with magnesium specifically. And when they react with magnesium, they are going to form what we call organomagnesium compound. And this organomagnesium compound is named after the scientist, which is Grignard. In 1902, he was the one that discovered this. And they name it after him. That's why we call it Grignard reagent. So Grignard reagent is when you have an R, an X, and most importantly, magnesium. In your question, nobody will tell you. Question 2 is under Grignard reagent, my dear. So therefore, they will just say, when methyl magnesium bromide, whenever you see magnesium, is Grignard. Most times when I saw question like that, I used to even forget that we even did Grignard. The year he taught us this, it was the last topic, so we not even think that we asked the question. So in the exam, I'm just saying methyl magnesium bromide react with water. I was like, which one is this? Did he teach us this? Later, I remember that this is Grignard reagent. I have even solved rubbish, and this is Grignard. I know it now. But it was not stated that it is Grignard. Nobody will tell you that it's Grignard. So your atom, what we able to know that this is Grignard is when you see the word, the statement magnesium. When you see magnesium, it is Grignard. So when you put magnesium into acrylamides, that's Grignard agent. So you can see ethyl magnesium bromide, that's Grignard. Now, when you now have ethyl magnesium bromide, I will give you assignment. So ethyl, this is methyl. Ethyl should be C2H5. Ethyl magnesium bromide is example of Grignard reagent. Ethyl bromide is not Grignard, it's acrylamide. Ethyl magnesium bromide is Grignard. Ethyl bromide is acrylamide. Ethyl magnesium bromide is Grignard. Now, when you now want to perform reaction, this is before class. What is this? Ethyl bromide. When this thing is ethyl bromide, bromine has partial negative charge, while acryl group has positive. So when we want to perform any reaction, LiPo repels or LiPo what? Attract. That means the minus person will go and pick the what? The plus in the reagent. In water, who is the plus in water? When water dissociates, what we have? Hydrogen and what? And OH. So if OH minus want to go into the chain, where is it going? In ethyl bromide. It's going to ethyl, right? Why H plus will go to the bromo. But in Grignard, the charges has been exchanged. The presence of that magnesium has transferred the minus on the halogen to the alkyl group and has taken the plus on the alkyl group back to the chlorine. So when magnesium comes in, what happens is that the magnesium transfer this minus to the air and give plus to bromine. When magnesium comes into place, the alkyl group is always minus, while the halogen is now the plus because of the magnesium. Now, imagine, I'm just showing you my mechanism. If you now add water, reaction 1, if you add water to this, it will be H plus and what? OH minus. When we go to the alkyl group, hydrogen on LiPo attract. Get it now? So what will be the answer? Ethane. If it reacts out together, follow. What I'm saying is that normally acrylamides, alkyl group is plus, halide is minus. When you put magnesium inside, magnesium has exchanged the charge. So the alkyl is now negative, while the halogen is now positive. So when you are adding any reagent like water, water will split into H plus and OH minus. It is always plus to minus and minus to plus, because unlike charges attract. So if this compound wants to attract, and this is H plus and this is OH minus, where will H plus go? To go here. Why OH will go what? We go here, right? So when the answer is now going C2H6 plus what? MgOH Br. So when you react ethyl magnesium bromide with water, you are going to get what? Corresponding alkane. Ethyl will give you ethane. Pentyl will give you pentane. Hexyl will give you hexane. I'm just showing you the mechanism. The mechanism is that the plus hydrogen will go to the alkyl group, because the alkyl group has a partial negative charge, which was because the magnesium transferred it, exchanged it. So class, what is the charge on alkyl group in alkyl halide? What is the charge of alkyl group in alkyl halide? Plus, what is the charge of alkyl group in Grignard reagent? Minus. That's how it works. Go online, go and search for reaction mechanism of water, Grignard versus water, Grignard versus CO2, Grignard versus methane. They will show you the mechanism. The mechanism is always that the nucleophile will always go to the MGBR, the electrophile, which is hydrogen ion. Now in CO2, what happens is that carbon is the one that goes to the chain. I will take time to do the mechanism for you guys. I just give you this instance so that you will know how it happens. So actually, this compound is OH that is supposed to go inside. The reason why H plus go inside is because of the magnesium. Magnesium has transferred the charge. It has exchanged their charge. That's why alkyl group is now taking negative. Normally, alkyl group should be positive. It was because of the magnesium that brought the anomaly. Thank you very much for coming, and God bless. It's my privilege. See you some other time. Thank you. So I